Hey everybody, welcome to video 22-2, part A. We're going to be talking about independent events, and specifically what does it mean, how is it that we're able to determine whether two events in our probability calculations are independent or not. So I'm here on page 1149 in our Explore, and we're looking at our definition here of independent events highlighted at the top of the page. When the occurrence of one event has absolutely no effect on the occurrence of another event, then the two events are called independent events. So basically, one thing happening does not affect the other thing happening. So that's what we're looking at here. An example of some independent events here is we're looking at part A, and we are talking about just a jar that has some marbles in it, 15 red and 17 yellow marbles. So it says we randomly draw a marble from the jar. Let R be the event that you get a red marble, and let Y be the event that you get a yellow marble. So since the jar has a total of course, 15 plus 17 is 32 marbles, the probability of getting a red is the total ways for that to happen, 15 out of 32 total, and the probability of getting a yellow is 17 out of 32. So for part B, once we've calculated those probabilities, for part B says, okay, suppose the first marble you draw is red, and then you put that marble back in the jar before randomly selecting a second marble. Putting that marble back is the key to this whole problem, okay? But find the probability of yellow given red. Basically, of getting a yellow on your second draw when you've gotten a red on the first draw already, okay? So let's explain through this. Since the jar still has a total of 32 marbles because you've placed that marble back, and still 17 of them are yellow, then the probability of getting a yellow after getting a red is the same as it was before, 17 out of 32. Part C says, suppose that you don't put the red marble back in the jar before randomly drawing a second marble. So you do not put the red marble back. Now we're still calculating, finding a probability of getting a yellow given that you drew a red. But notice what happens now. The probability that you get a yellow marble on the second draw after you've already gotten a red marble on the first draw, well, the jar now, if you didn't put the marble back, is down one marble. So we're down to 31 marbles. And you've drawn a red one, so you've not affected the total of the yellow marbles. 17 of them are still yellow, but the probability has now changed because it's 17 out of 31. Now I've done this in blue versus red so that you can see hopefully the distinction here. In the case of part C here, we would have a changed probability. So notice the probability of one thing happening is different because of the way that you encountered the first event. So going back to our definition again, when the occurrence of one event has no effect on the occurrence of another, the two events are called independent. So let's look at our reflect question. The reflect question says, in one case you replaced the first marble before drawing the second, and in the other case you didn't. For which case was the given conditional probability of yellow given red equal to the initial probability of Y? So here we go. There's my probability of Y. In which one of these two cases were the probabilities the same as our initial just getting a yellow with no other initial conditions? And of course, that is in our case of replacing the marble case, which was B above. That's the only one where we got the same probability, okay? Reflect question 2. In which of the two cases would you say the events of getting a red marble on the first draw and getting a yellow marble on the second draw are independent? The independent is the one where one probability does not affect the other. So, of course, that would have to be also case B. Okay? What is true, and this is kind of the crux of this exploration here, what is true about the probability of yellow given red and the probability of just plain yellow in those two cases? That would be that the probabilities are the same. Okay, so the conditional probability has to be the same as just the probability overall in order for the events to be independent. So we're going to see what that looks like with some actual examples in our next video, but that's just a nutshell explanation of what it means for events to be independent. We'll see you guys in the next time.